So this is section 3.2 rotation. So you'll need your tools for this section. So make sure you have protractor, ruler, compass, that kind of thing. Okay, so the first thing we've got here is counterclockwise and clockwise. So when we go counterclockwise, it's basically opposite of the way the hands on a clock go. So the hands on a clock, which would be clockwise, goes in this direction. Okay, so it's going to go around kind of, if you start at the top, you're going to the right, and then down, and then kind of coming around the left side. When you go counterclockwise, you're going the opposite way. So if we start here at the top, we're going around like that. Okay, so counterclockwise is that one, and then clockwise is that one. Okay, so when we do this for rotations, we're going to put a positive and a negative with those. So when we do counterclockwise, that's always going to be positive, and when we do clockwise, that's always going to be negative. Okay. So the first thing we're going to look at is on the example sheet, which you'll have to go, I think it's listed as like additional resources or something like that. On the Google site where you found this video, there should be something in there with a PDF with different things that you can print out to help you kind of go through the notes. So this would be under that. So we are going to look at the first example here in that. Okay, so it says in the figure shown here, the dotted ray from C to A, the dotted ray C to A represents the direction that Kathy is facing. Okay, so Kathy is here, she is C. The ray from C out through A is where she's looking. Next thing here is Kathy's dog, Susie Q, is running around Kathy in a counterclockwise direction. So Susie Q's here, going around in this direction. Okay, and then Kathy's field of vision is 140 degrees. Okay, so field of vision is what she can see. Just like we did the fox example and the rabbit example, field of vision is what she can see. So if Kathy's facing straight ahead, she can see inside that wedge there. Okay, so then it says how much of a turn is necessary so that she can see Susie Q directly behind her. Okay, so the dog's running around, and the dog is going to end up back here. So the dog is directly behind Kathy. So what we need to figure out is how far we need to take Kathy's field of vision and turn it so that she can see the dog directly behind her. Okay, so we've got Kathy's field of vision here in yellow. So what we're going to do with Kathy is we're going to take her, and we're going to turn her so she's right here seeing in this direction directly behind her. So if we know this whole thing is 140 and we're assuming she can see the same out of both eyes, so each of those chunks for the right eye and the left eye would be 70. So if we think about it here, if we take her, this would be her left kind of edge of the field of vision, and we turn her to directly behind her, if this is 70, if we think about this line here as like a diameter or making this a semicircle, from A all the way back here to whatever this letter was that I kind of made black there, from A all the way around there, that's 180 degrees. And if she can already see to the 70 degree mark, we got to figure out how much further she needs to go. So if we take 180 and subtract off 70, we get 110. So from there to there is 110 degrees, so that's how much farther she's got to turn so that she can just barely see Susie Q, the dog, directly behind her. And then since we are going counterclockwise, if we look back to our notes here, counterclockwise is positive, so this would be positive 110 degrees that she's got to turn so she can see her dog. Okay. Okay, so that was example 1 on our sheet. Next thing, we're going to do activity 1 that's on page 120, and this is also on the sheet. So activity, it's actually the back page of this here. So we're going to do this activity here, and it is on page 120, so I got to look at the directions. Okay, so the directions for the activity say we're supposed to trace the picture. Well, we've already got the picture here. If you don't have this printed out, you could just trace the one that's in the book. And we are supposed to rotate this triangle here 100 degrees about G. Okay, so a couple things here. If it's 100 degrees and it's positive, that means we need to go counterclockwise. Okay, so we're going to be pulling the triangle in this direction. Okay. Next thing we know is it's about G. So what that means here is we're turning it around G, which is our kind of going to be our center point. So we're going to take this triangle here, we're going to turn it around that point G, so our triangle should end up over here somewhere. Okay, and I think that's our only direction. So let's try this here. So you will need your protractor and you will need a ruler. Okay, let me get my sheet here. Okay, so with your protractor and your ruler, first thing that we need to do with these is we need to take and connect our point that we are turning around or about, so G, out to one of our points of our shape. So if we take and we connect G out to O, and I'm going to use a couple different colors here so I can kind of see which line is which. So if I take and connect G to O like that, then the next thing I want to do is I want to take my protractor and I want to put the center of my protractor on my center of rotation, or the point that I'm going around, which would be G. So I'm going to take the center of that protractor, put it on that point G. Now I've got two ways to do this. I could put my protractor on top here, or I could put my protractor underneath. Okay? Having the two options like this, one of them's right and one of them's wrong. The correct way is on top like this, because I want to pull this shape in the counterclockwise direction. So I want my angles to be coming off this way. If I moved and did it upside down like this, and I went to make my angles, then my angles would be coming down here, and that would actually be pulling this shape in the clockwise direction. So since I want to go counterclockwise, I got to have my protractor on top. So then what I do is, since I want to go to 100 degrees, I line up the center of my protractor on that point that I'm going around, and then I put my 0, 180 line, which would be that bottom line there, on my pink line that I drew in from G to O. Then I need to measure out to 100 degrees. Now when you're using your protractors, you've got 100 degrees here and 100 degrees here. Okay, so you need to be careful and use the one that is here, okay, because the one that's over here is going to be obtuse. And we know that 100 degrees is obtuse, versus if we chose the one over here, which would actually be 80 degrees, which would be acute. So you want to choose the one that's going to make the obtuse angle. Then what we do is we shoot a line from our center of rotation G out to our little tick mark that we just made out there. Something like that. So that should be a 100-degree angle that we just made there. Then what we do is we are going to measure from this point G out to this point O. Usually I use the centimeter side of my ruler just because it's a little bit easier to read. So I'm going to go from G out to O, which is about 7.5 centimeters or 75 millimeters. Then I'm going to do my same exact measurement. So 75 millimeters from G out on that line. Okay, and I'm going to put a point there. Now I'm going to label that point as not just O, but O prime. Okay, after we do our rotations, we call those the prime points. So I went O to O prime. So I rotated this point O here, 100 degrees counterclockwise. Now it's right there for O prime. I repeat the same exact process with the point Q and the point P. So like say I'm going to do P next. I would shoot a line from G out to P. Okay. Then I measure my 100 degrees, so center of my protractor goes on my center of rotation. Line up my protractor, 0, 180 line on that line I shot out there. Then I measure out my 100 degrees, making sure 100 is obtuse. Then I shoot my line out from the center out to that little tick mark I made. Then I'm going to measure from G to that point P that I'm trying to rotate. So I'm going to go G to P, see how far that is, maybe 46-ish millimeters. Then I do the same exact measurement. I shouldn't use my purple ruler because it's hard to see. Make my mark there. And that point is going to be P prime. Okay, and then we do the same thing with Q. And I like to do these in different colors so I can kind of see my lines that I'm drawing here. You don't have to by any means, but I like to do it in different colors because it's easier for me to see. So now I'm going to go G to my Q. And then I'm going to measure my 100 degrees. So line up center of my protractor on my center of rotation. 0, 180 line is going to go on that green one that I just drew. Then I'm going to make my mark here at 100 degrees and shoot my line out from my center of rotation G out through that tick mark. Okay. Now those two lines are pretty close to each other, but if you look over here in our original picture, they were pretty close to each other there as well, so it makes sense that they're close to each other. Okay, so then what I want to do is I want to measure my distance from G out to Q, which is about 81-ish. And then I do my same measurement here, 81-ish. And I'm going to label that one Q prime. Okay, so then to get my final picture, what I do is I'm going to take and I'm going to connect those points in the same exact order that they're connected over here. So my P goes to Q, Q goes to O, O goes back to P. So I'm going to connect those 3 points there. See, close enough. Okay, so if you look here, our original triangle should be the same exact or really pretty close shape to our new triangle. It should just be moved over 100 degrees around this center point G. Okay, so that's what we call a rotation, turning something around that center point. Rotation is turning. Okay, so that's that one there. Next thing here, we've got some definitions. So we've got pre-image and image. So pre-image is the original figure in the transformation. So if we look back to our activity here, our pre-image, and maybe you want to label it here, our pre-image was the one that was printed on the piece of paper, the one before we did any moving. So this one was our pre-image. Okay. And then after we actually move it, so the result of applying a transformation, so transformation is just some sort of movement to the original figure, that would be our image. So our pre-image is our before picture, and then our image is our after picture. Okay. Okay, next thing, center is what we're rotating around. So back to this picture here, the point that we were going about, G, that point was our center or our center of rotation. Okay. Next thing, magnitude of rotation. So that's the degrees rotated and then the positive or negative direction. Okay, so magnitude, how far we're turning it, and then if it's clockwise, it's negative, and if it's counterclockwise, it is positive. Okay, and then they do actually have some symbols that we use for rotation. So how the symbols work is big R means we're rotating something. So the big R here is rotate. The next thing, they'll have the letter that's listed as our center of rotation, and then we'll have the number for our magnitude of rotation, and then the point where, or the picture we're actually moving. So an example here, they want us to rotate some triangle, ABC, clockwise 100 degrees about G. Well, how we could write this out, we do a big R because we're doing a rotation. Our center that we're rotating around is G. So we do a little G here. And then the next thing is our magnitude of rotation. So since it's clockwise, that would be negative. And then our 100 degrees. Okay. Then you also want to put the shape that you're moving. So you go parentheses, triangle ABC. Because that's the shape they want us to move, the negative 100 degrees, about point G. Now occasionally they'll leave out that point G there. So if they did rotation of negative 100 and then triangle ABC, that's the same exact thing. I would say that it's probably more common to not have the center point there because usually there's only like one point that you can actually rotate around in the picture. But sometimes they do have it like that. Either way is fine. This one's a little bit more specific, but it really doesn't matter too much. Okay, the next thing is talking about rotations that are more than 360 degrees. So we know that 360 degrees is a full circle. So if I need to rotate 750 degrees in a counterclockwise